This segment is going to talk about working with angles that are formed by intersecting lines, both parallel and non-parallel lines. So what I've done here is I've drawn two lines, one going from left to right and one going from bottom up and top down. So just so we can see, there's one line going that direction and one line going this direction. And they're going to meet here at this intersecting point where I've got a point. Now as soon as I do that, I create four angles, and if I have two intersecting lines, I'm always going to create four angles, and it doesn't matter 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter what order we're doing them in which configuration we have it in, we're still going to create four angles. What I want to note is that we're going to produce some angles that have certain characteristics, and they will always have these characteristics no matter how we set up our diagram. In the basic angles video, we talked about angles that create a straight line. So I've got an angle here, and if I measure it, it gets 148, which is an obtuse angle. And I also create an angle here, and I ask it to measure it, which is 31. And if I tell the computer to calculate those, that one plus this one, I get an answer of 180 degrees. And that's because I've got a line from A to B to D, and a straight line always has an angle of 180 degrees. So these two angles, angle ABC and angle CBD, together have to add up for a total of 180 degrees. And if I play around with my angles, I can make this angle quite small. I can make it an acute angle of 66, but then this is going to have an obtuse angle of 113. And we talked about that in the last video, and we can see that the same thing happens in this situation as well. It's also important to note, though, that this is a straight line, but then so is this, from this point here all the way up. So if I ask the computer to measure this one, it comes out to 28 degrees. And if I ask EBA to be added to ABC, I'll once again get 180 degrees. And that's not surprising, or it shouldn't be, because EBC is a line, and if I take my acute angle here and my obtuse angle here together, that forms a 180 degree line. So these angles that we've been talking about, these are supplementary angles. And they may be called linear pairs of angles because they make a line, and linear has the word line in it. The next thing I want to point out is when we have our intersecting lines again, still the same kind of intersecting lines, it also produces angles that are found here, ABE and CBD. These ones here kind of bow tie shaped, and I'm going to ask the computer to measure those, and we notice that they're the same. And if I change my angle a little bit here by changing, they're still going to come out to being exactly the same. These angles are called vertical angles, or vertical pairs, or vertically opposite angles, and we make this bow tie situation take place, and they are the same. We're also going to produce ones at the top and the bottom that are also vertically opposite, and so they will also be the same. I'll have the computer measure those, and we can see those are the same as well. And if I change my diagram at all, and I slide things around so it looks quite different, my two vertically opposite angles that are side by side are the same, and my vertically opposite angles that are above each other are also still the same. And if I can move them around so that they are quite elongated, we still get the exact same pairing showing up. So these are called vertically opposite angles, or vertical pair angles. So now I'm going to add some more lines. So here I have two lines going sideways and another line crossing both of those lines. That line that crosses both lines is called a transversal. It trans across the lines. So it's called a transversal. And when we make this transversal, it produces 8 different angles that we're going to talk about here. And we can see that we have some vertically opposite angles. There's a pair, one there and one there. We have another pair here and here, another pair here and here, and another pair here and here. So we have these vertically opposite pairs, and we know that they're going to be equal to one another, even though we've added more lines to our diagram. So we've got that crisscross vertically opposite pairs going on. And those are the only ones that we could really pick, because this one here in the top right hand corner is quite different. We know this one's going to be supplementary to this one here, and this one here will be supplementary. We know this one here and this one here will be supplementary, as well as this one and this one, and this one and this one. We know those will be supplementary. We know that this one and this one together make a line, so they're supplementary. This one and this one together make a line, so they're supplementary. This one and this one make a line, so they're supplementary. This one and this one make a line. This one and this one make a line. This one and this one make a line. So we have lots of supplementary ones that add up to 180 degrees, but there's really nothing I can say about this one up here and this angle down here, because the angles are very different. In the next diagram, I'm going to talk about parallel lines, and we're going to see how all 8 of these are related to one another. So now I'm going to ask the computer to make some parallel lines for me. So I'm going to start off with a line there, and I'm going to put a dot down here, and I'm going to ask it to construct a parallel line to this one. And so if this one up here changes, then the one below changes as well. So they're always going to stay parallel. So we're going to start off with some parallel lines, and we're going to throw a transversal through them. And so there's our transversal, and we've got all these angles that we talked about before, the 8 angles that we've talked in the previous screen. So here's our parallel lines with our transversal through the middle, and I've created some vertically opposite angles. My 2 orange ones are the same, and my 2 gray ones are the same. I'm going to also do the diagram down here for the bottom for the vertically opposite ones down here. And here are my vertically opposite angles on the bottom, my kind of bow tie shaped ones again. And if I tell the computer to display all the hidden ones, so here I have my ones on the top and my ones on the bottom. So we have these ones are the same, these are the same, my greens are the same, and my purples are the same. These are my vertically opposite angles. So there they are, numbered and color coded. So up here all my vertically opposite angles, 1 and 4, 2 and 3, 5 and 8, and 6 and 7. These ones are equal to each other. And here are the supplementary angles, the ones that add up to 180, 1 and 2, 1 and 3, 2 and 4, 3 and 4, 5 and 6, 5 and 7, 6 and 8, and 7 and 8. Keeping this diagram the way it is, I'll notice that angle 2 here, HG, and this one over here, angle 2, is the same as angle 6. It has the same measurement. It has the same shape. And so angle 2 and angle 6 are called corresponding angles. Angle 3 and angle 7 also have the same angle and the same measurement. So those are also going to be called corresponding angles. And I'll continue to go along and try to color code the other corresponding angles. Angle 1 here is going to be the same as angle 5 down here. Angle 4 is going to be the same as angle 8. So I'll include those as corresponding angles. So there's the list of our corresponding angles, and it tends to form like an F shape. Here's a backwards F here, cross, down, and across. Here's an upside down backwards F, and number 2 angle with the number 6 angle, and the number 3 and the angle 7. The corresponding angles are kind of like the F angles. Vertically opposite kind of make an X angle, supplementary just make a line. I brought back the previous colors to show alternate interior angles. Interior means the ones inside my 2 parallel lines, and alternate means the ones that are on opposite sides of my transversal. So let's take a look at something. I know that angle 2 and angle 3 are equal to one another because up here we said they were vertically opposite. There's our bow tie. We also know that angle 2 and angle 6 are the same because they're corresponding angles. Well, if 2 is equal to 3 and 2 is equal to 6, then 3 should also be equal to 6. So this angle 3 has to have the same measure as angle 6. And if we take a look at it, it's an obtuse angle, and angle 6 is an obtuse angle. And I'm going to just have the computer calculate their measurements for us so we can see that. And we can see that they're 128 and 128. And if I was to change my diagram a little bit, they would still change 120, 121. And so all these things stay together. So this angle 3 and angle 6 would be an alternate because they're on opposite sides, and interior because they're in between the two parallel lines. We also have another pair, 4 and 6. If I know angle 1 is equal to angle 4 because they're vertically opposite, and angle 1 is equal to angle 5 because they're corresponding, then angle 4 must also equal to angle 5, and they're alternate interior angles as well. They kind of make a Z shape, and this one made a backwards Z shape. I know there's a lot. There's only one more left to go. If we take angle 2 and say angle 2 is the same as angle 6 because they're corresponding angles, and we know that angle 2 and angle 4 make a straight line, so that's 180 degrees. Then if 2 is the same as 6, and 2 plus 4 equals 180, then 6 plus 4 have to equal 180 as well. And so I'll show that with the computer. So here we have angle 2 is 128 degrees. 128 plus 51 is going to give me 180. And here, if angle 2 and angle 6 are both the same at 128, then these two have to add up to 180. And so I'm just going to have the computer calculate that for me. And here it is here, angle 4, which is the KGI, and angle 6, which is the GIJ, together add up to 180 degrees. And so I'm showing here that angle 4 and angle 6 together added up to 180 degrees. These are these two angles here that we said added up to 180 degrees, and therefore angle 3 and angle 5 together also have to add up to 180 degrees, and adding up to 180 degrees is another name for supplementary. So angle 4 and angle 6 are supplementary angles, and angle 3 and angle 5 are supplementary angles. So as you can see, when we have two parallel lines and a transversal, we have lots of different angles that are being created that have certain characteristics. Some of them are supplementary, some of them are equal to one another, and some of them are supplementary again. So there's a wide variety with lots of different names, and a little bit of practice is necessary. And we can see that if I change the shape of my picture and I change my parallel lines, the angles still come out to the same. There's lots of numbers here going on in this picture right now, but we can see that these pairs of angles stay corresponding or supplementary no matter how we set up our diagram or where we put our transversal.